What's going on, YouTube? Today we're going to be talking about AI and what powers AI, or what the industry is leading towards being one of the main drivers behind powering the AI, which is nuclear energy. See what I'm saying? So when we're thinking about AI, everybody thinks semiconductor chips, and that's great, but when you're an investor, you have to think a little deeper. Not only do we want to be invested in the companies that are forging the way for AI, your Mag 7, all the typical companies. And then we think about our semiconductor chip companies. We'll talk about, which we talk about a lot on this channel, your TSMCs, your NVIDIAs, your AMDs, your Broadcoms, your Microns, all of those different companies. You have to be thinking, okay, AI is taking over the world right now. It's involved in everything from our tech to the cars we drive to military defense to drones. It's taking jobs. We have agentic AI, we have robotics. We have all of these things that AI is powering. Well, we already know, everybody knows, semiconductor chips, is driving the AI. But one thing that we can't forget is the data center business. Data centers are essential for powering the AI. You need a lot of compute power. You need storage. You need the infrastructure. Data centers are essential. And when it comes to data centers, we are going to need a ton of energy. We're going to need a ton of energy. And when it comes to energy, there's one that keeps coming up and coming up and coming up. And it's a great source of energy, and that's nuclear energy. So that's what we're going to talk about at the end of the video. I'm going to give you an investment that I have a position in. And by the end of the video, this is not investment advice, but by the end of the video, if you like what you've seen, maybe you start a position. I think that this investment is good to pair along with your semiconductor chip stocks, along with an ETF like an SMH or something like that. So let's get into it. Then at the end of the video, I'll give you the investment. Let's get into it.
A ChatGPT query uses about 10 times as much electricity as a Google search. That difference is the catalyst for a new era of energy consumption, one where our evolving technology demands are now reshaping how the US and the world power our future.
Nuclear energy at a turning point, seeing momentum as power demand jumps from electrification and data centers.
Nuclear power and technology, or big tech getting involved in it. Nuclear power has sort of gotten back into the conversation.
We're going to be way ahead of AI, and we've got to produce tremendous amounts of electricity.
We're in the midst of a nuclear renaissance right now, and that's because power demand is meaningfully rising for the first time in a few decades. And at the moment, we just don't have enough clean energy options to meet that power demand from things like reshoring, electrification, as well as data centers.
This is why big tech is betting on nuclear power. Data centers around the world, built by tech giants like Amazon, Microsoft, Meta, and Google, are hungry, not just for AI training sets, but for energy. Artificial intelligence, driven by massive computing power, is reshaping not only how we work, but also how we think about energy consumption.
What AI did is it escalated the power demand at individual data centers by a factor of 10, or even 100 if we're looking forward into the future. That means those are data centers that are needing power along the same scale as entire cities.
The Department of Energy estimates global electricity demand could rise from a third to 3/4 by 2050, with the US energy grid seeing an unprecedented strain. Data centers powering artificial intelligence and cloud computing will be among the biggest contributors to this growing demand. Energy use was already slowly ticking up, but oil and gas prices skyrocketed as energy powerhouse Russia invaded Ukraine in 2022, and geopolitical volatility was on the rise.
That's really when these dialogues started to happen again in earnest, the idea of what does energy security, what does energy independence mean, and that's when we saw countries start to look at nuclear once again.
As OpenAI introduced ChatGPT to the masses in November 2022, the buzz and investment around large language models put the US on a path to an AI future and the energy demands that come with it.
It wasn't the tech companies' problem to understand how electricity worked. They knew that they could build a data center, plug into the grid and there was enough power. And then their marketing people made sure that they had enough renewable energy credits to claim that they're actually using renewables to power their data center.
And so really right now, everyone is trying to play catch up of how are we going to meet all of these power demand goals as well as reduce our emissions. And so that's where nuclear comes into the picture. Solar and wind are great, but they're intermittent resources. That means that it's not always sunny, it's not always windy, so they aren't 24/7. And what nuclear is it's 24/7 baseload emissions-free energy.
Major tech companies are leading the charge. Just last spring, Amazon agreed to a nuclear power purchase agreement with Talon Energy in Pennsylvania and bought the adjacent data center from Talon for $650 million. Now, Amazon is investing over $500 million into a number of nuclear power projects ranging from Virginia to Washington state. Microsoft is working with Constellation Energy to reopen the 3 Mile Island nuclear facility with plans for $1.5 billion in upgrades there. Meanwhile, Bill Gates founded TerraPower is also working on a plant in Wyoming. Then there's Google, who's working with startup Kairos Power to bring advanced reactors online in the next decade, though no dollar amounts have been announced for those investments yet. Meta also says it's looking into nuclear power, targeting 1 to 4 gigawatts in new energy capacity. But these investments and partnerships are becoming an industry-wide trend, all driven by a shared belief. Nuclear is the only solution.
The tech companies have a vision of the world based on AI. That world is only possible if they produce a large amount of clean, steady power. That's why their work into nuclear now is fundamental to whether their entire world vision can come true.
These are existing and retired nuclear sites in the US with space for new reactors. The next step in the sustainable transition is to design, build, and bring those new reactors online alongside the existing ones. Enter SMRs, or small modular reactors. Unlike traditional reactors, SMRs are smaller, faster to build, and more cost-effective. They produce around 300 megawatts of energy compared to the typical 1 gigawatt output of traditional plants, and their modular designs allow for off-site assembly, reducing construction costs and build timelines. Tech and energy companies are working to bring several of these reactors online over the next decade as incremental steps toward a broader energy transformation.
You can assemble them at a factory and then bring them to the site for the final assembly versus having to build it from scratch on the location. And so that's what's traditionally been done with commercial reactors, and that's why they've often been very expensive. And so there's a lot of hope that with these smaller modular reactors that are about 300 megawatts or even micro reactors, which can be tens of megawatts, that could kind of address some of the issues of these cost overruns.
SMRs don't operate much differently than traditional reactors, but the efficiency gains they do offer will be important for intermittently scaling our energy future.
Obviously, there's a role to build still some of these plants, but small kind of scales more naturally with how demand growth goes, especially when you look at the AI side and data center space. A lot of sweet spots are in the couple hundred megawatts in terms of total usage, but those are building up in dozens of megawatt chunks per time. So they themselves are modular. So the smaller plants really can match that growth more organically.
While SMRs hold promise, they're still a few years away. All plans in the US are currently slated to open in 2030 and beyond. Right now, there are no SMRs operational in the US, and regulatory approval will remain a challenge for years to come. There are also experts who say our nuclear solution should be a combination of these new, smaller output designs in addition to building more traditional commercial reactors.
While the SMRs are cheaper up front, they also provide meaningfully less power. And so while there's so much momentum behind SMRs, there are others that say we really need new commercial scale reactors to meet our energy goals and to meet our climate goals. And right now, there are no commercial reactors under construction in the US.
I think that for a country like the United States, the natural process is we need an enormous number of large reactors, like that's how much power we need, is that SMRs will be a way to open up the conversation. SMR gives us a term that sounds like it's new and advanced, so it makes a lot of people a lot more comfortable talking about nuclear.
Okay, so what we just seen. In order to do all the things that we want to do with AI, in order for all of our major tech companies like our Metas, like our Microsofts, like our Amazons, Teslas, in order for all of these companies to be able to do what they want to do when it comes to AI, we're going to need a lot of power. We're going to need a lot of energy. And this is a way that we can get a 24/7 clean source of energy, nuclear power. We already have 94 nuclear power plants active. We have some that aren't active, and we don't have any small modular reactors. Now, we have things like Project Stargate. We know they're going to be developing a lot of infrastructure. We're going to be putting up a lot of data centers. You already see companies like Meta announcing 60 to $65 billion market caps building out infrastructure. You see our companies like Nvidia, AMD generating billions of dollars in data center business. So this is something that's growing. This is something that is expected to grow very quickly over the next 5 years from 2025 to 2030. So we're going to need a lot of power. We're going to need a lot of power, and people are turning to nuclear as that source of power. So here you see nuclear plants in the United States. We currently have 94 nuclear reactors that power tens of millions of homes, anchor local communities, etc. But we're getting a lot of data centers popping up all over the United States. And these 94 nuclear reactors that we have, it's not enough power, it's not enough energy to go around for all of our homes, all of our local communities, and data centers. It's not enough power, so we're going to need more plants. We're going to need the small modular reactors. We're going to need to, activate some of those vacant nuclear plants. We're going to need a lot of power. We're going to need a lot of power. So small modular reactors, we heard her talk about that. What's the difference between a conventional reactor, a small modular reactor? So, as you can see here, we have this pulled up. The large conventional reactors produce 700 plus megawatts. Small modular reactors up to 300 megawatts. Now, as you can see, they've talked about these small modular reactors being a way to, kind of speed up the process, because these large conventional reactors take a lot of money and they take some time to build, to establish, to set up. These small modular reactors would be something that is cheaper and faster, but as you can see, it produces much less power. So, we already have some tech companies, looking into, hey, we need to build these data centers. We don't have conventional reactors many places. As you can see, we just looked at this map. We just looked at this map, and they're building these data centers at a lot of different places, and we don't have enough of these conventional power plants to go around. So that's why they're turning to these small modular reactors to kind of fill in that gap and be able to provide extra power at a cheaper cost and faster. So, with that being said, let's go here. This is an article. Google and Amazon make major inroads with small modular reactors to bring nuclear energy to data centers. Top hyperscalers agreements and investments in Kairos Power and X Energy small modular reactors could move these companies' technologies to the forefront of SMR design. So you see companies like Google, Amazon gearing up to start investing money into these small modular reactors to give them more power for their data centers. You see, this is something that is actively going on. It started getting very serious in 2024, 2025. You can expect to see more of the same on over the next 5+ years to come. This is something that's happening. It's something that's happening. Google, they formed their relationship with Kairos Power. They announced an agreement to eventually build up to 7 small modular reactors, providing up to 500 megawatts of power, with the first unit to come online in 2030 and the project to be completed by 2035. So you can see this is something that, these companies are gearing up for. You know, they're getting the semiconductor chips, they're building out the technology. We have things like Project Stargate. We're building out the data centers. We're building out the infrastructure. These companies are working on our large language models, and they're also gearing up to do what? Get the nuclear power to power the revolution, to power the data centers, which the data centers are going to power the AI. Are you starting to see how it all is one big family? In order for the AI, you need the semiconductors. In order for the AI and the semiconductors to be functional, you need the data centers. In order to power the data centers, you need a lot of power. That's where nuclear comes in. You see what I'm saying? That's where nuclear power comes in. Now, 3 reasons why nuclear is clean and sustainable. Nuclear energy protects air quality. Nuclear zero emission clean energy source. That's always good. Nuclear energy's land footprint is small. That is always good. And nuclear energy produces minimal waste. These are all things that, when you're talking about nuclear, we talk about fossil fuels and all of that thing, protecting the earth, going green, low emissions. And this is a way to, kind of buy by that and get the extra power we need at the same time. So now it's time to tell you, the investment, the play. We talk a lot about, of course, everybody knows the big tech companies, the Mag Sevens, the other companies that are putting billions and billions of dollars into AI, and they're behind the technology and the large language models and all of that type of stuff. And you know about your semiconductor chip companies, like your TSMCs, your ASMLs, your NVIDIAs, your AMDs, your Broadcoms. You know about all of these companies, but what I don't see many people talking about is, you see people talk about the data center business as well, but a lot of people don't stop and think. I see a lot of people investing into the companies, investing into the semiconductor chip stocks, and that's fine. I do the same thing as well, but try to take a step back and say, what is truly powering this technology? What's powering the data centers? You need a lot of power, you need a lot of energy. And when you're thinking about that, this is where this comes in. This is a fund provided by State Street. It is called XLU. It is a utilities sector fund. Now, what's in this fund? See, remember I told you it's utility sector. So you come down here and you look at the holdings. We're going to look at the holdings. And as you can see, let me go to this quarter in. This is year to date. This is in the last year's time. As you can see, there's a big spike in this fund's performance. I wonder why. You know, AI is taking off, these data centers taking off. The need for power is becoming more and more. Nuclear power, energy is becoming bigger. We need more. And that's why you see the fund performance. You can see it's been doing great year to date and over the last year. And you can expect to see, this performance continue to tick up and see bigger years. So we look down top holdings. Top holdings. Now, these are some of the biggest utility companies in the United States. Now, what I want you to be thinking about, you may look at these, okay, what do these utility companies have to do with nuclear? Why don't we just go invest in, these big tech companies? Because, they're trying to create small modular reactors, right? They're okay, yes, that's fine. But this is something that you want to pair. This is something that I'm pairing along with my tech companies, along with my semiconductor chip stocks. This is also a defensive play because when you're talking about utility companies, they tend to perform well during the economic downturns. So not only is this a smart play for that, it's a defensive play. Now, look at these top holdings. We just got done talking about nuclear. What is a way that I can expose my portfolio? Because if you're like me, you already have the tech companies covered, you already have the semiconductor chip stocks covered. How can I expose my portfolio to the nuclear side of things? How can I be exposed to that? How can I take advantage of that and allow my portfolio to be able to see some residual from all of this nuclear energy, that we're going to need, and that my tech companies, you know, they're going to need, and my semiconductor chip stocks, as a residual, they're going to benefit from this as well. All of the, I won't say all of these except for American Electric Power and Sempra, I believe. All of these other holdings, the top holdings in this fund, this XLU fund, this utilities fund, they all have nuclear power plants. See what I'm saying? They all have nuclear power plants. So, by investing in this utilities fund, you're getting exposure to not all, but you're getting exposure to a lot of the biggest players in the United States when it comes to nuclear power, when it comes to these power plants. You know, you already invested in the tech companies, you already invested in the semiconductor stocks. If you believe in AI, this is a way that you can get exposed to what's going to be powering the data centers, what's going to be powering the infrastructure, what's going to be powering the compute power, what's going to be powering the storage. It's what I want y'all to get to thinking about. We got to start thinking deeper. This is a play that I've started a position in. The current price, what's the price of this? The current price is 79.40, and we can go look up the performance just to show you guys before we get out of here. Man, don't keep popping that up. XLU utility sector, as you can see, it's been going down a little bit. But let's look at it year to date. Well, let's look at over the last year. As you can see, the last year, AI had a massive year 2024, having another massive year in 2025. These data centers are taking off. AI is taking off. All of this infrastructure and capex being spent on all of the data centers and infrastructure and AI. All of these things are taking off. Nuclear power is starting to become more prevalent. It started to become more prevalent last year. It's starting to become more prevalent as time goes by. You see some of our major companies are starting to invest into the space. They're starting to think about small modular reactors. They're starting to think about conventional reactors. The power is going to be needed. You can see the fund is going up. And I believe you can expect to see this fund have a lot of growth over the next 5 to 10 years as you see data centers, infrastructure, as you can see AI continue to progress, as you can see the need for power, nuclear power to continue to be more and more in demand, as you see these small modular reactors pop up, as you see more conventional reactors start to be developed. I think this is a fund that will see a lot of residual from that. I just wanted to share this with you guys because this is something that I've been paying a lot of attention to. Something that I've been paying a lot of attention to. And I just wanted to put it on you guys' mind. Put it on you guys' mind. And I would be remiss if I didn't show you this because I like to give people their flowers. I like to give people their flowers. And this is the young lady. I don't know how old she is, but she is brilliant. I follow her and learn a lot from her. She is brilliant. This is her page. This is one of the first people I've seen on X start to talk about XLU. And she is one of the people who got my gears turning and starting to think a little deeper when it came to AI and nuclear power. And I just want to give her a credit, give her flowers. Shout out to Vaughn. You know, she put me on a play, and now I'm paying it forward, putting you guys on to the XLU play. And I think it's great. I think it's great. As I've done my research, it's all starting to come together. And just want to shout out with you guys. Shout out to Vaughn, man. Shout out to you. Go follow her if you don't. She is an amazing resource. And she's a gem. She's a gem. She's a gem. She's a gem. But without further ado, that's it for this video. Please like, share, subscribe. If you got anything, if you got any value, help me grow. See what I'm saying? And also, man, follow your boy. Go follow your boy. Shameless plug. Go follow your boy on X. Haven't been on X very long. I think my account is old, but I've only been active on X for probably the last couple of weeks, last month. Go tune into your boy on X. And yeah, I ain't gonna hold y'all no longer. Just want to put y'all on the play, talk to y'all about AI, nuclear power. I'm yapping. I tend to do that. But I'll see you on the next one, man.